Problem 7. Here we have three resistors. Let's say we have 1, 2, 3. They have the same value, 100 ohm. The maximum power, P maximum, that can be safely be delivered to any one resistor is 25 watt. So the power of one resistor equals to 25 watt. What I mean? For example, okay, let's continue before. What is the maximum potential difference that can be applied to the terminals A and B? I have to find the maximum potential that can be applied here. Let's say delta V max. I want the value between A and B. Before, you know here, delta V max will deliver here I max. If we have I max, here we get a power max equals to 25 watt. Okay? So here we have I max, and here we have I max. This I max will be divided to two parts. Here we have I1 and here we have I2. Okay. Now I want to find delta V. To find delta V, for example, let me calculate before the equivalent resistance of this circuit. Before, here we have R1, and we can calculate the equivalent of 2 and 3. Okay, we can say here R equivalent to 3, we have a parallel resistance which is equal to R2 times R3 divided by R2 plus R3, which is equal to 100 times 100 divided by 200. We can calculate R equivalent to 3, which is equal to 50 ohm. Okay, and here we have delta V between the point A and the point B. Now we can calculate the equivalent resistance between the point A and B. And here also we have A and B. R equivalent. Here we have 1 and 2, 3 are in series. So R equivalent total equal to the summation of 1 plus the equivalent of 2, 3, which is equal to 100 plus 50 equals to 150 ohm. This one equals to 150 ohm. Okay, delta V max here will give here I max. To find delta V, we have to find the value of I max. For this resistor, I give you P, I have R, we can calculate I here, which is equal to I max. Okay, you know here here we have I max. So here we take the resistance 1, you know, P max for one resistor equals to I square times R. If we have P max, here we have I max. So we can calculate I max, which is equal to radical P max, which is equal to 25 divided by 100. So we get the value equals to 0.5 watt, 0.5 ampere. Now we calculated the value of I. We come back here. We have I, we have R. We can calculate delta V. So delta V, you know delta V at the resistance equals to delta V at the battery because we have the same node. So delta V maximum equals to R equivalent times I maximum. So which is equal to 150 times 0.5 equals to 75 volt. Okay, so finally we have delta V max 75 volt, and we calculated I max equals to 0.5 ampere, and we have R equivalent equals to 150 ohm. Part B, we use the same voltage determined in part A. What is the power delivered to each resistor? Okay. You know, here for this one, we have 25 watt. Why? Because here we have I maximum. Okay, so here we have I maximum, here we have I1, and we have I2. As we have the same resistance here and here, so we have the same value of I1 here and I2. I maximum equals to 0.5, so I1 must be equals to I maximum divided by 2 equals to I2 equals to 0.5 divided by 2 equals 0.25 ampere. Okay, so here we have, we can calculate P1, no, it's P2, and here we can calculate P3. So P2 equals to I2 square times R2, which is equal to 0.25 square times 100 equals to 6.25 watt. And here also P3 equals to I3 square times R3 equals to 0.25 square times 100, which is equal to 6.25 watt. Here, what is the total power part C? I want to calculate the total power delivered to the combination of resistors. You know, to calculate P total, here we have R equivalent and we have delta V max. And here we have I max. So from this circuit, we can calculate P total, which is equal to I max square times R equivalent. Okay, the total. Or we can add 25. Okay, and here we can calculate the total P will be the summation of 6.25 and 6.25. From here we have 25 plus from here we have 6.25 plus 6.25. We get the total equals to 37.5 watt. We can calculate like this, or we can do it here. I maximum equals to 0.5 square times 150. We get 37.5 watt. Okay,